Welcome to this complete guide on AI in DevOps, focused on intelligent software delivery. We'll explore how AI transforms continuous integration and continuous delivery automation into advanced AIOps. Our video covers 10 key areas. We start with an introduction, discuss the traditional DevOps challenges, and then dive into AI-powered solutions, including CI/CD pipelines, intelligent testing, AIOps, and DevSecOps. AI in DevOps integrates artificial intelligence and machine learning to automate, optimize, and enhance the software development lifecycle. Key goals include automating repetitive tasks, predicting failures, and optimizing resource usage and code quality. Traditional DevOps faces challenges such as manual bottlenecks, alert fatigue, and long mean time to resolve incidents. Scalability gaps and security lags also hinder performance, costing significantly more to fix post-deployment. When AI/ML intersects with DevOps, it creates AIOps and MLOps. AIOps applies AI for IT operations, improving monitoring and anomaly detection. MLOps focuses on applying DevOps practices to the machine learning model lifecycle. AI transforms every stage of the CI/CD pipeline. This includes AI-powered code reviews, predictive build caching, intelligent test selection, and deployment automation using risk prediction models and canary scoring. Intelligent test automation delivers impressive metrics, including an 80% reduction in maintenance time and a 60% decrease in escaped defects. AI is crucial for smart test selection, auto-generated cases, visual testing, and flaky test detection. AIOps, or AI for IT operations, cuts through operational noise and accelerates mean time to resolve. The AIOps platform uses AI for log analytics, event correlation, anomaly detection, predictive alerts, and auto-remediation. Predictive analytics and monitoring use ML algorithms to establish performance baselines, predicting anomalies before they impact users. This enables failure prediction, proactive capacity planning, and intelligent SLA management. AI dramatically reduces MTTR through intelligent incident management. Stages like detection, triage, and investigation are accelerated to seconds or minutes. Remediation and post-mortem are also largely automated. AI-driven security, or DevSecOps, shifts security left by embedding checks throughout the pipeline. This includes static code analysis, dynamic analysis, container scanning, and behavioral models for threat detection and response. MLOps brings DevOps principles to machine learning, ensuring a continuous loop from data preparation to monitoring and retraining. Key components include data versioning, experiment tracking, model registry, feature stores, and CI/CD for ML models. AI and infrastructure as code makes IAC smarter by generating configurations, detecting configuration drift, optimizing costs, and predicting misconfigurations. This includes AI-generated IAC, drift detection, and cost optimization recommendations. Natural language DevOps, or ChatOps combined with large language models, allows engineers to manage operations via chat. Use cases range from triggering deployments and querying logs to generating runbooks and suggesting fixes for failures. AI tools like GitHub Copilot and Tab9 focus on code generation and completion. Tools like CodeRabbit and Amazon Code Whisperer aid in code review and security. Deepcode/Snyk specializes in vulnerability detection using ML-trained models. AI significantly drives cloud cost optimization, with an average cloud cost reduction of 35% using AI tools. AI can recover billions in wasted cloud spend and is rapidly being adopted for cost governance. Many real-world AI DevOps tools and platforms are available across key categories. These include tools for CI/CD intelligence, monitoring and AIOps, security, code assistance like GitHub Copilot, and MLOps platforms. Implementing AI in DevOps follows a roadmap, starting with a foundation phase to audit pipelines and identify AI entry points. This progresses to expansion with AI test automation and AIOps integration, culminating in intelligence with predictive failure detection and MLOps. AI dramatically improves DORA metrics. Deployment frequency increases multiple times a day, lead time for changes drops to under a day, and the change failure rate falls below 5%. Mean time to recover can be reduced by a factor of 16 times. Key risks in AI DevOps include over-automation, data privacy/IP leakage, and model drift. Mitigation strategies involve human-in-the-loop approvals, using private AI models, continuous retraining, and prioritizing open standards to prevent vendor lock-in. In Kubernetes and container operations, AI enables intelligent autoscaling, optimizing pod placement for cost and performance. It powers anomaly detection in pods and resource management, cutting cloud waste significantly. Leading tech companies demonstrate AI at scale. Netflix uses AI for chaos engineering and capacity forecasting, saving over $30 million annually. Google leverages ML for build caching and code review, and LinkedIn uses AI safety scores to block risky releases. The future of DevOps is autonomous. We progress from AI-assisted tools today to augmented systems by 2026 and semi-autonomous decisions by 2028. By 2030+, we anticipate fully autonomous, self-healing, AI-native software development lifecycles. Your AI DevOps action plan begins by measuring your DORA baseline and identifying bottlenecks. Then, deploy quick wins like Copilot and AI code review. Finally, build competency with training and scale the tools org-wide, continuously measuring ROI. In summary, AI in DevOps is a competitive necessity. Start with AI-assisted code review and AIOps for the highest ROI. Remember, the path to autonomous DevOps is incremental, augmenting human creativity with AI intelligence at every stage.